Fire sprinkler systems are among the most effective and widely used methods of active fire protection in modern buildings. Their quiet presence above our heads, often overlooked, belies a sophisticated engineering solution capable of saving lives and protecting property. As a fire protection engineer with years of experience in system design, inspection, and implementation across residential, commercial, and industrial buildings, I can confidently say this: understanding how fire sprinklers work is not only essential for engineers and safety personnel but increasingly important for architects, building owners, and even the general public. In this essay, I will take you through the science, components, activation mechanisms, types, and real-world applications of fire sprinkler systems, while also addressing common misconceptions that still linger today. To begin, the fundamental purpose of a fire sprinkler system is to detect and suppress fires automatically in their early stages, before they escalate into uncontrollable blazes. Contrary to popular belief, sprinklers are not activated by smoke but by heat. The science behind their operation is rooted in thermodynamics. Each sprinkler head is equipped with a heat-sensitive element, either a glass bulb filled with a liquid that expands when heated or a metal fusible link that melts at a specified temperature. These elements are calibrated to burst or melt at a preset temperature, commonly 68 degrees Celsius 155 degrees Fahrenheit, which is typical for offices and residential buildings. Once this threshold is reached due to the buildup of heat from a fire, the sprinkler activates, allowing pressurized water to flow directly onto the fire. Now let's look at the anatomy of a sprinkler system. At its core, a sprinkler system consists of a water source, a network of pipes, control valves, alarm systems, and the sprinkler heads themselves. The water source could be a municipal supply or an on-site fire water tank connected to fire pumps that maintain the pressure needed for distribution. The piping network distributes water from the source to various parts of the building, segmented into zones for better control and maintenance. Valves, especially the main control valve and zone valves, are critical for isolating parts of the system and ensuring manual operation if needed. Alarm valves are integrated to send electronic signals when flow is detected, simultaneously alerting occupants and the fire department. The true heroes, however, are the sprinkler heads. These come in different designs including upright, pendant, sidewall, and concealed types, each suited to a specific architectural layout. A question I often hear is, when one sprinkler goes off, do they all activate? The answer is no. Only the sprinkler head exposed to the heat of the fire will activate. This localized response is one of the greatest strengths of sprinkler systems. It conserves water, minimizes water damage, and ensures that the system responds only where and when it is needed. This precision is enabled by the fact that each sprinkler operates independently based on the temperature surrounding it. For example, if a fire breaks out in a kitchen corner, only the sprinkler head nearest to that fire will discharge water, while the rest of the system remains dormant unless heat builds up elsewhere. There are several types of sprinkler systems, each designed to meet the demands of different environments and hazards. The most common is the wet pipe system, where the pipes are constantly filled with pressurized water. These are reliable, low maintenance, and react the fastest since water is immediately available. However, they are not suitable for environments where freezing temperatures may cause the water in the pipes to solidify. For such settings, dry pipe systems are used. In these, the pipes are filled with compressed air or nitrogen. When a sprinkler head opens, the air pressure drops, triggering a valve that allows water to flow in. This introduces a slight delay but ensures pipes won't freeze. Then we have pre-action systems, which are hybrids commonly used in data centers, museums, and other sensitive areas. These systems require a two-step process. A fire detection signal, usually from a smoke detector, must first be confirmed before the valve opens to fill the pipes with water. Only when a sprinkler head then activates due to heat will water discharge. This prevents accidental discharge and is ideal where equipment or assets are irreplaceable. Deluge systems, on the other hand, have open sprinkler heads and are used in high-hazard areas like chemical plants or aircraft hangars. When a detector senses fire, a valve opens and water is released through all heads simultaneously, blanketing the entire area. Fire sprinkler design is a technical discipline governed by international and national codes. The National Fire Protection Association, NFPA 13, British Standard BSEN 12845, and IS 15105, Indian Standard, are some of the most widely used design standards worldwide. Design engineers must calculate hydraulic demand, pressure loss, and flow rate requirements to ensure that each sprinkler head discharges enough water to suppress the fire. This involves a process called hydraulic calculation, which considers pipe lengths, diameters, friction losses, and elevation differences. The outcome is a detailed design drawing that shows pipe routing, sprinkler spacing, head types, and water supply requirements. Sprinkler spacing is determined based on hazard classification, light, ordinary, or high, defined by the materials present and expected fire loads. For example, a library with books and wooden shelves may fall under ordinary hazard, while a warehouse with flammable liquids is classified as high hazard. Maintenance is another crucial factor in sprinkler effectiveness. Regular inspection ensures the system will function during a real emergency. Sprinkler heads should be free from paint, dust, or corrosion, and never blocked by furniture, decor, or false ceilings. Control valves must be locked in the open position, and water flow alarms tested monthly. Wet systems require annual flow tests, while dry systems need trip testing. Neglected systems often give a false sense of security and have tragically failed in numerous historical fires. Training and drills should also be conducted to ensure building staff and occupants understand how the system works and respond correctly in case of activation. Technological advances are also revolutionizing fire sprinkler systems. Smart sprinklers equipped with IoT sensors can detect changes in temperature trends, flow rates, or valve status and send real-time data to cloud-based platforms. Building management systems, BMS, can now integrate fire sprinklers with HVAC and security systems for coordinated emergency responses. In high-rise buildings, multi-zone systems with pressure-reducing valves are used to ensure balanced discharge across multiple floors. There is also growing use of ESFR, early suppression fast response, sprinklers in warehouses and industrial facilities. These specialized heads deliver a high volume of water at a fast rate, extinguishing fires before they grow, eliminating the need for in-rack sprinklers. Let's not forget the economics. One of the most compelling arguments for fire sprinklers is their return on investment. Statistics from NFPA and other international fire agencies consistently show that buildings with functional sprinkler systems experience significantly fewer fatalities, lower property damage, and reduced insurance premiums. In fact, a properly designed and maintained sprinkler system can control 96% of fires with just one or two heads. For residential occupancies, where fires often start at night when people are sleeping, sprinklers provide precious seconds for evacuation and limit damage to a single room rather than the entire home. Despite all this, myths persist. Some people believe sprinklers go off when a person smokes indoors, or that cooking smoke can activate the system. Others think sprinklers cause more damage than the fire itself. These misconceptions stem from Hollywood dramatizations and a lack of awareness. In reality, sprinkler systems are finely tuned, reliable, and scientifically validated to perform in highly specific conditions. They are engineered not to create chaos, but to bring structure and control to an otherwise unpredictable emergency. In conclusion, fire sprinkler systems are a marvel of safety engineering, simple in principle, yet deeply complex in execution. They exemplify how passive infrastructure can be turned into an active guardian of life and property. From the moment a flame begins to rise, to the precise second when the sprinkler detects heat and releases a controlled burst of water, every component is working toward a singular goal: to save lives and limit destruction. As we build smarter, denser cities and more sophisticated facilities, the role of fire sprinklers will continue to grow, not just as code compliance measures, but as intelligent safety systems embedded into the very architecture of resilience. If there's one message I'd leave you with, it's this: a properly designed and maintained sprinkler system is not just an option, it's a life-saving necessity.